Thank you for introduction. I'm Tarutani. I'm with Power Device Works of Mitsubishi Electric Corporation. Okay, I came from Fukuoka Prefecture in Kyushu, Japan. And it is a great honor to be given this opportunity today. Thank you very much. And today, in this title, I'd like to introduce examples of application of power devices to EVs, firstly. And I will give some application examples of the factory automation manufacturing in our lab. And finally, I will add some latest industrial power module topics in short. Maybe this kind of products could be used for your products. Okay. This is the introduction slide. And currently, in order to aim for a carbon-neutral society, various industries are accelerating device development and expanding production. And electrification is the keyword for many things, of course. And this view graph shows the whole picture of the world. And there is 3 categories and generation of the electricity, and transmission, distribution, and electric application. This similar slide is also presented by Dr. Hu. And in particular, the solar and wind power plant is very important nowadays. And in addition, the power conversion equipment is required in power transmission distribution scene. And there is many kinds of power modules used, and various voltage and current related is needed in this area. And so in Mitsubishi, we are doing a power module manufacturer, and so we are very busy about this kind of area. And also in energy consuming scene, the light half of the part. And there's also the various devices electrified in our workplaces and also the living spaces. And modules that can reduce the power consumption of these devices is very necessary. Under these circumstances, Mitsubishi Electric manufactures power modules products that can use in a variety of applications. Okay, this slide shows the main power modules and the related devices of Mitsubishi. We must produce such kind of devices. These are the power modules used for the various applications. And our module can deal with, for example, the 600 volt to the 6.5 kilovolt voltage class. And also ampere, rated current ampere is from 3 ampere to up to about 2,000 amperes module we are producing. Such kind of the wide varieties are our products. And the energy innovation with power device is our power phrase of this business. And also here, changes for the better is Mitsubishi Electric's power phrase. So we are doing our business with this kind of words. And this is a history of our power module development. And so this is very detailed information is listed here. So if you have time to pre-check, read at this one. But I'd like to address, first, IGBT groups are developed in 1980s earlier. And now we are enhancing the properties and nice products can be made in this area. So it takes a very long time to make the present latest generations devices. So this is our history. And also we're doing SiC, silicon carbide device production. And that research was started just around 2000. And 2010s, we are the world first manufacturer using the SiC modules, power modules. This is our histories. And this figure shows the wafer process-based side of Mitsubishi Electric power devices. Device design is development and design is done in Fukuoka site, and I'm sitting in the fourth floor of this building, so this is my position. And the wafer process mother factory is here, is located in Kumamoto, and so of course the Kumamoto is very famous in Taiwan because the reason is maybe you should know the reason, and that big huge company's fab is just very close to our main mother factory of the power device works in Kumamoto. And in addition, we have another process fab site in, for example, the Fukuyama in Hiroshima Prefecture. We have one site, and in Kitaitami in Hyogo Prefecture, we have another process site. We are processing such kind of wafers, silicon and SiC. And I just mentioned about the IGBT process. So the power dies, power chips, or such kind of IGBT conducts the current from top side to the bottom side. And so there are two electrode sides in the dies or in the wafer. So we need surface side process and the back side. We have backside process. We need two kinds of process. And surface process is done, of course, in Kumamoto. And also, we're using some foundry services, for example, domestic and overseas. So, but today's talk is in Taiwan. So, as the overseas word is something strange using in here. So. But we are using the foundry service of the wafer process. And I would like to express my heartfelt gratitude to the teams. And this is because they are active in manufacturing power devices for white goods and also automotive applications. This is very important information today. And there is many processing tools in the fabs, as you know. And this, for example, this is a Kumamoto site clean rooms machine layout. Just image, not a real one, just image. And in here, we are doing 200 millimeters SI silicon wafer processing. And there are many tools, and we also, of course, using some factory automated systems like overhead shuttles and automated guided vehicles. And also, here is some rails and the traversing robot for high-speed moving is used in such kind of processes. And this is not so new design, but I would like to add the information that Mitsubishi, firstly started the production of the DRAM in this fab. And the factory automation system is already installed in 1990 or before 90. So Mitsubishi is early adapter of the factory automation process machine in the wafer fab. This is our history. And we added some small some new point is we are doing a SiC 150 millimeter SiC wafer process in the same area, in the same fab. By using some new cassette, the outer shape is for the 200 millimeter wafers, and the inside is designed for the 150 millimeter SiC wafers. So by using this kind of specialized cassette, we can use the same factory automated system, the silicon, and we are doing manufacturing the SiC, MOSFET, or Schottky barrier diode in this product line. So there is some special process tools for only for used SiC, and the other is only for used silicon. But of course, that system is controlled by the central computer, so no mistake in the transfer or processing occurs. So this kind of system is still working, and we are doing production, both silicon and SiC in the same fab. This is our image, the current image. And there is also many factories used for assembly and testing of power modules. And just one information, for automotive modules, we are doing this manufacture at Fukuoka site. And this is some information about the new factories. And so the cumulative capital investment from fiscal year 2021 to 25 will be approximately 260 billion Japanese yen. This is for Mitsubishi is a very large, very huge investment, and specifically and we will newly install a warehouse fab dedicated to SiC, 8-inch SiC process, and in Kumamoto, also in Kumamoto. And the fab is expected to be operational in April 2026. And we plan to use the state-of-the-art clean room here, and also the factory automation product line and the systems. We are now designing and making a good this conversation with these manufacturers, process tool manufacturers. And more detailed information is posted on the Mitsubishi Electric's IR Day home pages. So please check this kind of information. And just changing the subject a bit, let me advertise that Mitsubishi Electric is contributing the IEC white paper project. The power electronics will be used in various applications, as I explained, and as you know. And this is a white paper to convey that things to the general public in an easy to understand manner. And it also touches on recommendations for standardization of product standards. And the project partner is MTAR, and more than 50 international experts participate in this project. And it will be completed late this year. So if you have chance to access the site, so please read it, this white paper, to understand the current situation. Okay, now I move to the topics of the power modules for EVs in Mitsubishi Electric. And this slide is shows the evolution of Mitsubishi Electric automotive power modules, and the history is at the beginning, and now it's like this. And the many generations devices are already in mass production, and we are doing the next generation development. And one point for our technology is shown here. We are using direct lead bonding structure instead of the wire bonding technologies to get more high robustness and high heat dissipation or long life. And also for the machining or for production side, by doing the wire bonding, the many action is needed, the many contact point is needed. But by using this kind of joining technology, uses one area is okay. So this kind of change is maybe good for the intelligent manufacturing or smart manufacturing, I think. And since 1997, our power modules is used in many kinds of hybrid vehicles and also EVs. And the number of the power devices used for the drivetrain, it has been reached more than 26 million xEVs on the road. This is a good number, I think. And we believe that high performance and high quality driving these growth. And this slide summarizes the features and benefits of our J1A module. And compared to the similar products from other companies, the module is 29% smaller and 53% lighter. And by using J1A, it is possible to make automobile inverters or e-axles very small. In addition, there are many benefits for the designers. For instance, the system cost reduction due to miniaturization. This is a very small module. And also securing or getting internal spaces. This is good for the designers of the product. And also increase of freedom of the automobile design and higher safetyness. Such kind of point is our strengths and our advantages of the J1A. And these features are achieved by the technology employed in J1A. So just in detail, we are using aluminum pin fin here with insulating substrate. This is the top side of our base plate substrate, and in the back side, we are making some aluminum pin fin in the backward side of this kind of plate. This is a newly adapted technology for the J1A, and it is very good for make the modules lighter and high efficiency cooling can be achieved by this kind of structure. And also, we added the direct lead bonding structure here. This copper electrode is directly connected to the IGBT or diode tips using the bondings. And also, in the third point is we are using direct potting resin to encapsulating that modules. So not to the silicone gel, but we are using epoxy type gels. This is a good point of the J1A. And this slide illustrates the benefits of the epoxy encapsulation. In recent years, the number of equipment installed outdoors has increased. And there are products that are required to improve the environmental resistance to, for example, corrosive gases. And as for the EVs, the environment under the bonnet hood may be very hot and very high humid. And now the earth is getting the boiling era. So this kind of necessity is increasing, I think. So, and in case of the gel encapsulation, permeation and migration of the sulfur components, for example, have been confounded by the test using corrosive gas conditions. So due to the nature of the silicon gel, this kind of dendrite growth cannot be hindered and stopped. This is nature of the materials. So if here is a high voltage electrode and the ground electrode, this kind of short risk can happen in the long range of the usage of this kind of modules. And instead, on the other hand, by capping the epoxy resin, by using epoxy resin capping, pretty sure this kind of edge of the electrodes, no such kind of growth, material growth is found. So this is a good point for the high reliability and environmental resistance to the corrosive conditions. And also, our module uses tips and frame and lower base plate. And in between that, we are using solder joint technologies. And we're using lead-free type solders. This is a cross-sectional SEM images of the very top interface of the dies and the solders. And here is the microstructure of the IGBT electrode portion. And one additional good point for the J1 is summarized as this slide. So as I explained, so we are using these technologies and no extra some conducting grease or some insulating grease is not necessary. So it has good advantages. So the degree of the freedom in module mounting angles. If you put on top of your modules, it is okay, and on the underside, it is also okay. And on the side, it can be mounted in this direction, because no grease is needed, and so this kind of connection is maintained in every angles. This makes vehicle design flexibility and mounting angle flexibility is one of the key points of our J1A modules. And also, this module is very light and small, and fixing the module is enough, only 4 points of the nut point. And also, the main terminal is connected by nut. For example, the 5 terminals can be connected by the nut. This is easy to assemble for the users. And I also I will not go into detail in today's talk, but the tip is equipped with temperature and current sensors, which can avoid destruction by providing first protection of the device when it enters overloaded operation mode. So this kind of protective function is very nice, and so the user can optimize the electrical design margins and on user side. This kind of function is very effective. Okay, this is a little bit secret slide, so I try to explain, keeping secret. The J1A3 has been used in various vehicles, and firstly, of course, hybrid electric vehicles use J1, and next the plug-in hybrid. And nowadays, the battery EV is using our silicon-based J1 modules. And by using optimal design conditions, it can be used to up to 150 or 60 or 78 kilowatt motor rating battery EVs. It can be used to these ranges. But now, currently, the Japanese automaker using J1 in the K car, lightweight EVs. This is also our result. So not only the usual previous hybrid vehicles, so battery EV using silicon-based modules is in mass production. It's present. And the compact tractors or some electric motorcycle is using our modules. This kind of this is the reality of the in EV. Still the silicon-based module is used. And the one special case is this Monster EV machines. They use this J1A module in parallel, and they install the three sets of them. So many modules they're using in their Monster EVs. Then, for covering the entire kinds of the EVs, so we need silicon and SiC, and we need some kind of module size design needed. But the next generation automotive module concept is that we are thinking is the covering the entire range by using one core module. This is our idea for the next generation. This is our concept of the transfer molded power module core pieces. And this one is two-in-one connection type. And this can be installed the silicon, next generation silicon RC-IGBT, and also the SiC MOSFET in it. And by using three of them, this can be used for the medium-sized class EVs. And by using 6 of them, the large vehicle size is applicable. So this standardized module can extend the very wide applications. So this is a good idea, I think, and we are very eagerly developing that. Okay, the left time is not so enough, but I will show you just a small example of our manufacturing example. This is the J1A module assembly line, and here is the machine A and the machine B, and we are using this kind of robot to handle the parts automatically. And of course, we are using our Mitsubishi Electric robot. And power device power module is very different kind of parts can be used. So this kind of intelligent robot and the gripper hand is very useful for our production line. By using this kind of system, we are doing very efficient manufacturing of our module. And also we are applying some alarm transmitter system in the wristwatch terminals to show to tell the workers of the machine's conditions. Okay, so finally, we are doing business for industrial usage, and our good point is intelligent power modules for that applications. That equips some sensor systems, so we can stop the malfunction before the fault. So this kind of usage, the function is very useful for the next generation factory automation, because in EV, the factory, the machine is getting larger and larger, and high power, more power is needed for that function. And so the control is very, control of stopping the malfunction is very important things, I think. So our module will be used this kind of areas, I think. So this is my summary of today's talk. I gave some examples of the our module usage in the EVs, and also our just short examples of our manufacturing scene. And the Mitsubishi Electric power device are used very wide applications. So, and let's share your new ideas to contribute to create a carbon neutral society and energy-wise society. Thank you very much.
Thank you very much. Thank you.